Hey guys, this is Professor Janacek, and I want to go over some examples of solving systems of linear equations. Now, you have notes and lecture videos on how to solve this using the echelon method and the Gauss-Jordan method. Both of these methods can actually be done with the calculator using the reduced row echelon form operation. Let's look at these examples. I'm going to be using the TI 84 Plus, and you should be able to do this on other TI 84 and 83, as well as the TI Inspire. You will not be able to do this on a scientific calculator, but most scientific graphing calculators will have an option. Again, scientific, not going to be able to do this using this technique, but most graphing calculators, you can use this approach. All right, so let's solve this first one. X over 4 plus y over 4 is equal to 0, and x over 4 minus y over 4 is equal to negative 3. The first thing we'll have to do is write this as a matrix, particularly an augmented matrix. Now, our calculator won't distinguish between regular matrices and augmented matrices, so that won't really matter. But let's go ahead and write it as an augmented matrix. This is 1/4, 1/4, 0 for the first row, 1/4, negative 1/4, negative 3 for the second row. I will put that vertical line there. This is what makes it augmented. That vertical line represents where the equal signs are. And notice that I have simply written this by lining up my x's, my y's, my equal sign, and then the constants over here. Okay. Now, before we work any problem, you do want to always make sure that it is lined up. Now, you could have this lined up really in any way as long as the constant is on the right. You could have y and then x, and then your equal sign, and then the constant, as long as the equal sign and constant are always there at the end. And as long as the variables are lined up, all will be good. So this is our matrix. Now we're going to go to our calculator and type this in. The way we'll do this is we'll go to, turn it on, and then second X inverse. You'll notice that it says matrix just above that, and that's why I needed to use the second button because it's in blue. Now I'll go over to edit. I'll just scroll over to edit, and then I'll go down to whichever one I want. I'm going to go ahead and put this in matrix A. I'll make note of that here, call that A. So now that I've got matrix A selected, I'll simply hit enter. Now I do need to determine the size of this. Notice we have 2 rows and 3 columns, so the size of this one is 2 by 3. So I'm going to type that in first, 2, enter, 3, enter. And you'll notice now it shows the matrix, all the matrix elements are 0. So let's go ahead and type in those values. I can simply type in fractions or decimals if you prefer. Let's go ahead and type those in. I've got 1/4. I am using the division sign as a fraction, and you'll notice that it shows up here at the bottom. 1/4 for my first term. It does change it to a decimal, but that's the setting that this calculator is on at the moment. 1/4, enter for the second one, 0 for that third term. The second row, I have 1/4, enter, negative 1/4. So I am going to use that negative at the bottom here, and then 1/4. Again, you'll see it shows up. It's negative 1/4 here. Enter, and that puts it there. And then negative 3. Again, make sure you're using the negative sign and not the minus sign for this. This is not subtraction. This is making it a negative value. So negative 3 and enter. So now you see all of my terms here. What I have here is in fractions. It's now written there in my matrix. Okay, so I've got it all entered. Now I can exit this. I'll do second quit. And now we're ready to put this into our calculator. We're going to, you should have the notes on this, but I'm just going to kind of show you where to go. I'll do second matrix over to math, and then all the way down to RREF. Make sure you're using R REF. There is an REF, but that's not what we want. We want RREF. So make sure you select that one. So again, I went to matrix, over to math, down to RREF. Now I'll select that by choosing enter. And now you'll see on the screen I have RREF. Now what I need to do is I need to go get matrix A. The way to get a matrix, to retrieve a matrix, is to do second matrix again. And now I just need to go and select it. Here's their names. I want to highlight A, the one that I have here, enter, and there we go. So now we have RREF on A. Again, RREF is for reduced row echelon form. Once we have that, then we enter, and it shows that we get the matrix 1, 0, negative 6, 0, 1, 6. I'm going to go ahead, because I know this came from an augmented matrix, I will write it again as an augmented matrix. So all I did is record these values here. Okay, as a reminder, this is the X column, the Y column, the equal sign, and then of course the constants there at the end. So what this is telling me is that formally, this is saying, if I go back to an equation, this is saying 1x plus 0y is equal to negative 6. 0x plus 1y is equal to positive 6. Of course, I can simplify that. This is the same thing as saying x, get my pencil to work, x is equal to negative 6 and y is equal to positive 6. So my solution is the ordered pair, negative 6, 6. And there we go. Not too bad, I hope. Let's try the second one here. Now the second one looks like it's going to be much more complicated because it has all these decimals, but it shouldn't be too bad at all. So first thing, I want to make sure that everything is lined up. I have my x's, my y's, my z's, and my equal to. Right? That's all good. So I can write that as my matrix, 2.6 for the x, 14.9, negative 2.0, and 2.8. That's the first row. The second row is 5.6, negative 7.0. Oh, I don't even need to write the positive. 1.6 and negative 4.4. The third and final row is 2.4, 8.4, negative 4.9, 8.7. Again, I know that this is an augmented matrix, so I'll put that vertical line there to identify where that equal sign is. Again, this column, the first column are the x values, the second column are coefficients of y, the third column, coefficients of z, and then that vertical line shows me that equal sign. All right, so now we're going to put that into our calculator. Again, to do that is second and that x inverse, which is the matrix, and then over now to edit. I'm going to go ahead and put this in spot B, so I'll name it over here. This is going to be matrix B, just so I can remember that. Select matrix B. Now I do need to type in the size. Remember the size of this one. It has 3 rows and 4 columns, so this one is a 3 by 4. 3, enter, 4, enter. So that gives me the size. And then it shows up again. I can always make sure that I've got that in the right order because I see 3 columns. And then, of course, I can scroll over and see that I've got 4 rows. All right, so going back to that first one, by the way, this identifies the first spot. So this is spot 1, location 1, 1. This is location 1, 2. I could go down to location 2, 2. If you ever get confused, where am I? This down at the bottom will tell you where you are. All right, so let's go ahead and type them in across the first row, 2.6, 14.9, negative 2.0, and 2.8. Second row, we have 5.6, negative 7.0, 1.6, and negative 4.4. The third row is 2.4, 8.4, negative 4.9, and that should be 8.7. So there we go. Everything's in the calculator. And again, I have entered that last one, so it shows up there. All right, now that I've got it entered, I can go ahead and get out of that by quitting. So second mode, which takes me to the quit, that gets me back to my home screen. Right, now what we're going to do is go get that RREF, that reduced row echelon form function. So again, that second X inverse to get me to matrix. Now I'm going to do math on this matrix. So I'll go over to math and down to RREF. Again, make sure you go all the way down to RREF, not the one above it. And I will select that. And now I'll go get my matrix. So that's second matrix. Now I just need to select it. I selected this was matrix B. So all I have to do now is go down to B and hit enter. So I went and got RREF, selected my matrix B. Now all I have to do is enter, and that gives me a big, long matrix. We end up with 1, 0, 0, negative 0.263. Now you'll notice this does go on quite a bit here. Follow the instructions for this one. I'll go ahead and round to the nearest tenth. I'm doing this because all of my numbers here originally were to the nearest tenth, so we'll continue with that. So it's negative 0.3. Notice I am following rounding rules. All right, the next row is 0, 1, 0, negative 0. Oh, maybe we should go one past that. How about 0.26, 0.03? Because it wouldn't make sense for that to be 0, although I suppose it could. And we have 0, 0, 1, negative 1.95. Again, just follow the rounding rules, or follow rounding rules, but also follow the instructions if it tells you how far to round. This is again an augmented matrix where I've got the first column is X, Y, Z, and then equals, again, just following what I did up here. All right, so now going back to writing it as an equation. Again, you'll notice that this first it says I've got 1x, 0y, and 0z, but of course 0y and 0z, that's just 0. I don't need that. So this really just tells me that x is equal to negative 0.26. Similarly, the second row, I've got 0x, 1y, and 0z. That's really just my y, which is equal to negative 0.03. Then we have 0x and 0y, which is 0, and 1z, which is equal to negative 1.95. So as an ordered triplet, because there are 3 of them, this would be negative 0.26, negative 0.03, and negative 1.95. And there is our solution for that one. Let's try a couple more just to make sure that we're okay with these. Let's solve 4x minus 2y is equal to 7 and 8x minus 4y is equal to 35. Now you might notice something unique about this, but if you don't notice anything special about it, we'll see here in a moment that there's something kind of different about this particular problem. Again, I do want to make sure that everything's lined up. I've got my x's, my y's, and my equal sign. So when I write it as a matrix, I can do that x, y, and then the equal sign. So the first row is 4, negative 2, 7. Second row is 8, negative 4, 35. Write this as an augmented matrix in those matrix brackets. Put a vertical line where that equal sign is. And then we'll put this in our calculator. So again, second matrix, edit. Remember, we go to edit first. I'm going to go ahead and put this in slot C. I'll make note of that here. And I do need to put the size of this one. This one is a 2 by 3. That's 2 by 3. And now I can type in those values. 4, negative 2, 7 is the first row. 8, negative 4, 35 is the third row. Again, make sure you're using the negative sign for those negative values and not the minus sign. And make sure you enter after each one. Okay, so we've entered after each one, so that is now in there. I can go ahead and get out of this by quitting that screen and going back to my home screen. Again, that was second mode. And now we'll have to go get our function RREF. That is second X inverse to get to the matrix. Go over to math and scroll down to RREF. Select that by choosing enter. And now we have to go get our matrix C. Again, that's second X inverse to get us to matrix. Now I don't have to go to the right. I don't have to scroll over to math or edit. I just need to go select the one I want. So now I'm just going to scroll down to C, select enter, and there we go. Reduced row echelon form for matrix C. Hit enter after that, and that gives us the matrix. I do want to let you know, if you want to change this, say instead of doing a decimal, if you wanted to go back to a fraction, you could do that. Just simply change to your answer to a fraction. There are notes on that in the Notes to module, but I won't go over that here. So let's see, we end up with 1, negative 0.5, 0. We have 0, 0, 1. That is our augmented matrix. Again, this is X, Y, and equals. Put that there to remind me when I write it back in equation form what I've got. So here it gives me 1x minus 0.5y is equal to 0. The second one gives me 0x plus 0y is equal to 1. But 0x and 0y, that's just 0 is equal to 1. Uh-oh, that's not possible. 0 is not equal to 1. 0 is equal to 0, and 1 is equal to 1. You'll notice how this happened. In the calculator, I have zeros all the way across the bottom row, and except for a 1 on that very last spot there. So zeros across the bottom except for something other than 0, which is typically going to be a 1. That's going to give me a false statement. And if we get a false statement with this, that tells me this is very important. A false statement means that there is no solution. So that is what we get for this example. It's no solution. And that all comes down from having that 0, 0, 1 across the bottom. So all zeros except for a 1 across the bottom means that it's going to be no solution. All right. That was the unique thing. You can actually kind of see that in this particular problem, because 4 times 2 is 8 and negative 2 times 2 is 4, but 7 times 2 is not 35. So you could actually kind of pick that up. If you don't see that, though, from the beginning, not a problem. We get that here just by doing what we've been doing before on all of these problems. All right, let's take a look now at example 4. Things are already lined up. My x's, oh, I don't have a y in there. Notice I will want to put in there a 0y plus 0y. And then, of course, I have my z equal to negative 6. Okay, so I've got my x's, my y's, my z's, my equal sign. Everything's lined up, ready to go. Let's go ahead and write out these matrices. The first row is 1, 1, negative 2, 8. The next row is 3, 0, 1, negative 6. And then the final third row is 2, negative 1, 3, negative 14. Again, this is an augmented matrix. I'll make note that my variables are x, y, and z. I do want to let you know you could have different variables. Sometimes you have different letters rather than x, y, and z. You could also do this for larger matrices. You might have 4 variables and only 3 equations, or you might have more equations. So however, whatever this looks like, you can always write it as a matrix. All right, let's now go ahead and put this into our calculator. Remember to do that is second matrix and then over to edit. Actually, let me do this again, second matrix over to edit. I'm going to go down and put this into matrix D. Make note of that here. Now you could, of course, replace one of the previous matrices. That's not a problem. You could also clear them all out. Make sure you remember how to clear. It's not this clear. You're going to have to do a memory clear. But yeah, we can go ahead or you can delete them individually. So I'm going to put this in D. So go down to D, hit enter. Now we do have to put in the size. Again, this size is 3 by 4. 3, enter, 4, enter. And there we go. Type in those values. Hopefully you're getting the hang of this. All right, by the way, you can always scroll up or down through this matrix if you want to check your values, especially some of these larger matrices, you might not always be able to see everything. So feel free to scroll back, left or right or up or down, just to make sure, and you can always change any of those values. All right, but now that we've got it, we'll go ahead and quit this and go back to our home screen. And now we'll go get our function RREF. Again, second to matrix over to math. RREF, enter. And always nice idea to double check to make sure you grab the correct function. And now we'll go get our matrix. We're going to get matrix D, second matrix, and just go select it by name. Just scroll down. I don't have to go over to math or edit this time. And there we go. So we've gotten matrix D in there. Hit enter. And again, we've got a fraction. This time I will go ahead and write it as, because I noticed that 0.3 is a nice little fraction. Let's go ahead and change this to fractions instead of decimals. Math is what I've selected, and I want to change to a fraction, so I'll go ahead and just enter and enter again. And now we have that again. It was math, enter, enter to change to a fraction. If you want to change to a decimal, it would be math and then go down one and then enter, enter. Again, you can see this in the notes. So what we end up with is the matrix 1, 0, 1/3, -2 for the first row, 0, 1, -7/3, 10 for the second row. And then notice we have all zeros, 0, 0, 0, 0, all the way across for the third row. By the way, this is also a 3 by 4, so the matrix size never changes. So if you happen to type something incorrectly, you can hopefully easily notice if you've got the wrong size matrix. All right, but let's go ahead and finish this out. I know that this is an augmented matrix, and I know the first column is X, the second column is Y, third column is Z, and then we have equal to. So what do we have here? Well, this is X plus 0y plus 1/3 z is equal to -2. The next row gives us 0x plus 1y minus 7/3 z is equal to 10. And then the last row just really tells us that 0 is equal to 0, which, by the way, is a true statement. But it doesn't tell me anything about the values of z. So this one is basically saying that z can be any real number. So in this situation, what we have is infinitely many solutions. And all of that comes directly from this statement that 0 is equal to 0, or what we had in the calculator, zeros all the way across the bottom, zeros all the way across the bottom, which was different from what we had before, zeros and then a 1 there, different than zeros all the way across, including at the very end. So zeros and then a 1 is false, which is no solution. The zeros all the way across, which is a true statement, tells us there are infinitely many solutions. Now let's go ahead and talk about what those solutions look like. You'll notice if I take these equations here, this one, I have x plus 1/3 z is equal to -2. Let me just write that down. X plus 1/3 z is equal to -2. I could solve this and get that x is equal to, I'll write it as -1/3 z minus 2. Similarly, we have y is equal to -7/3 z, I'm sorry, y minus 7/3 z is equal to 10. Solve that for y. We get y is equal to, I'll write the z term first again, 7/3 z plus 10. If I get a common denominator here, what we have is x is equal to -1z minus 6/3. Notice that's, actually, let me work this out so you can see all of it. I don't want to skip too much here. You can see that x is equal to -1z/3 minus 6/3. So x is equal to -z minus 6/3. Similarly, y, I can get common denominator here. That's 7z/3 plus 30/3. So y is equal to 7z plus 30/3. So when I write this as an ordered pair, remember we write this as x comma y comma z. My x, though, is -z minus 6/3. My y is 7z plus 30/3. And my z is just z. Remember, I can choose anything for z. So this is what my solution looks like as an ordered triplet. In some cases, you simply write these equations, that x is equal to -z minus 6/3 and y is equal to 7z plus 30/3, and that z can be any number. All right, well, there you go. Hopefully you enjoyed these examples, and please email me if you have more questions. Bye.